Tracks for Europe up to 2050. As already mentioned in the introduction, there are different ways, let's say, how the stock of buildings can be renovated, and it's one of the challenges of our time to find solutions for that and to have a clear vision on how this task will go on, because it is not something which will be done today or tomorrow, but clearly due to the long cycles in the building sector, any decisions and actions that are taken in the next years will be decisive for what we will have in 2050. So this is a crucial time and moment, and I'm happy to have the opportunity to describe and show the outcomes of the study we did for Eurima, and to share this with the community out there. And for sure there will be much more things to discuss and bring to action to make things happen, and hopefully we can give a little contribution to that discussion and this knowledge in this area. So I will move in the presentation from the background of the study. So what's the challenge, to the methodology and way we looked at the issue within the study and the results, and then come to an outlook to see, okay, where might that carry us further, and then I'm looking forward to any kind of questions that come from the presentation and that we can still tackle in the 1 hour as just mentioned. So starting with the crucial question here, why renovation is so important. We hear that many times, and for sure it is not neglecting that the new buildings also pose a challenge. They also have to be very low in energy use and CO2 emissions. But it's also clear that major saving potentials on CO2 and energy are within the existing building stock. And also the way to let's say make them tangible and to unlock this potential are more difficult, because things are as they are and you need to work from a certain starting point. But it's clear that the savings can be huge, and so it's really one of the big challenges in the building sector to get that done. On the other hand, it's not only about CO2 and energy, it's also about reducing dependencies, especially from fossil energy sources, something which is very important as a political goal in the EU, but I'm sure all around the world as well, and also a means to avoid fuel poverty, which with raising energy prices is really getting a problem in various countries of this world. At the same time, building renovation, of course, also has the ability to improve comfort and the quality of life, because the buildings are more comfortable in thermal comfort and many times also in their visual in the visual quality and the look of the building. So it's not only a topic of CO2 or energy, and not only a, let's say, strategic goal where you look at dependencies or political dependencies even, but it comes also really close to the quality of life of people, which is an important goal in the EU and elsewhere. Then on top, job creation, green growth and technology development play a role, because especially in the refurbishment of buildings, quite some jobs are to do not only, let's say, in producing materials, but actively applying them on the buildings. So it's typically an area, the renovation of the building stock, which is connected to really new jobs being created if more of this is happening, and also to develop smart technologies that can help to achieve these goals. And basically, when it then comes to the question, why is it so important now to do the right decisions, the right step, this is mainly connected to the fact that basically there's only one chance really to do it right until 2050, because the building sector really has long renovation cycles, of 30 to 40 years, and renovation cycles meaning here the time between, let's say, two large actions that are done on the building, like renewing the facade or renewing the roof. These are really actions that are not happening like every 4 or 5 years, but really in these long durations. And then the graph at the bottom makes it clear that if we look now at these time spans, and we now have 2014, then this renovation cycle carries us way to beyond 2040 and even 2050 if you would assume 40 years. And that automatically makes clear that buildings that are renovated, for example, this or next year, will most probably be exact in that status after the renovation also in 2050. So while 2050 then seems really far away, obviously the actions that it triggers need to happen more or less already today. And that makes it not only important but also a pressing topic to have good solutions for that. Well, then also the question, if that all is so good and so wished to achieve, what makes it so difficult then? And there's of course a bunch of things that make it complex. On the one hand side, at the building owner's level, there's significant upfront investment necessary to get these measures done. They're mainly on the building envelope and the technical systems. And these are not things which are just, let's say, financed quickly out of pocket, but usually require people to go to a bank and have a loan. So there's something to really do there and organize. On the other hand, the renovation often really changes the look of the building. And in many times this is really an effect which is highly wished. But sometimes people are completely satisfied with how their building looks like. And then, of course, it gets a topic how the renovation will change that. Another topic is then the quality. So will the quality be all right? Will the savings really be achieved? Or will it maybe be more difficult than before? It's not that there are no solutions or that there are no, let's say, clear technologies and ways to get the quality. But at an individual level, it's always a question whether it will really work. And last but not least, we have the investor-user conflict, meaning that especially in rented out buildings, it's the owner of the building who does the investment, but it's the tenants who will profit from lower energy bills. And in some countries, there's a clear way how to deal, let's say, with the distribution of this burden or cost and the benefits, but it is also not everywhere and not always clear and how this needs to be split up and how, let's say, both people or both sides can optimally benefit from that. So that remains an issue still. But then going also beyond the building owner's perspective, there's a challenge at the country or the market level. And that lies within the fact that on building renovation, many stakeholders are involved if it's about renovation of the building stock. And they have really different views and also different positions and are sometimes heavily fighting for these. And that means these are actors like the policy level or the politics who want to drive things in a certain direction. It's the owners and investors that sometimes have a completely different view, whether it's good to have certain requirements or not. It's the tenants on their side also sometimes really hesitations. They are not looking forward to that. Others would really want that to happen. Then the building companies, they play a role, the producers, the architects, the engineers, the associations. So many people are involved in such a process. And as already said, they have different views. So if it comes to a real strategy how to do the renovation stock at country level on a long term, it's all these actors who need to align and who need to get to a, if possible, common view that things are really working and are not only put on paper. So having talked about the question, what makes it so important and what makes it so difficult, then the question is, okay, what does the EU now have in mind for the building sector in the long term? And there's a clear target stated. It's not a binding one, but a clear expression in the roadmap for moving to a competitive low-carbon economy in 2050, and that was released by the European Commission. And there's the long-term objective to decrease the CO2 emissions from the building sector by 88 to 91% in 2015, if compared to 1990 levels. So that's, in average, that's 90% of CO2 savings, and this is a quite significant number. So that means basically that only 10% of the emissions that were there in 1990 are allowed to remain in 2050. And this then poses the question, okay, how can we get there? Is it possible at all? And what kind of solutions could be there to achieve that? There's also, let's say, for a proper understanding of the policies and the guidance within the EU, there's not only this overarching aim for 2050, but there are also policies in place, directives in place, which at the EU level require certain action that the member states then have to turn into national regulation and comply with. For the building sector in the EU, that's mainly the EPBD, the Energy Performance of Building Directive. And when it comes to building renovation, the Energy Performance of Building Directive is putting forward the performance requirements for buildings. So it does not say anything about how many buildings should be renovated, but it says clearly something about the ambition level, how they should work. And so far, the requirement is that new buildings and renovation activities should come at a cost-optimal performance level. This is a mechanism where member states have to do a calculation with reference buildings, whether their current performance requirements for buildings are cost-optimal, or whether in the light especially of energy price raises in the last years, not higher performance requirements could be set up. So this is a mechanism that the member states have to calculate with and see whether they have to revise their national standards. On the other hand, for new buildings, there's another standard as from 2021 on, with the requirement that they should be nearly zero energy buildings with a very low energy consumption and a significant share of renewable energy. So far, this step from cost-optimal performance requirements to nearly zero energy buildings requirements is only set for new buildings. That's already clear. For the refurbishment of existing buildings, so far plans are requested from the member states how they think they should do things like that. So refurbishment of buildings not only to cost-optimal performance level, but to a nearly zero energy level, but this is not binding yet. So it's clear that the idea is already implemented, but it's still open how on the very long term the requirements will develop. So that's also one reason to have studies like the one presented now, to see what's necessary and what needs to be done in the future. Then on the timelines in the EPBD, as said already, for new buildings, just to keep the overview, there are currently cost-optimal requirements in force, and as from 2021, all new buildings have to comply with nearly zero energy building standard. And for public buildings, it will be a bit earlier in 2019 as a front runner. For retrofit, now cost-optimal requirements are in force within Europe, and there might be nearly zero energy requirements, but as stated already, this is not finally agreed or negotiated yet, and it's also uncertain whether it would come. So this discussion is still open, what happens on the longer run and whether cost optimal requirements will be turned into something more strict, for example, than after a certain time. Then also at the level of the EU, there's the Energy Efficiency Directive, which holds also requirements for buildings. And these are now more not on the ambition level that's clarified in the Energy Performance of Building Directive, but more on the activity level, so what needs to happen and how often. And in this directive, there's a clear requirement for member states to develop renovation roadmaps to exactly look at this long-term development and long-term strategy for their building stocks to be renovated. So this study hopefully can also be an addition to the thoughts of the member states and can hopefully be an inspiring input. Another requirement in the Energy Efficiency Directive related to renovation of buildings is the renovation of central government buildings. And the other requirement is that 3% of these need to be renovated each year. Now coming to the study performed for Eurima that was done in 2012. Sorry, I see there's still 2013 in the line, but it should be 2012. So at that time, the discussion was really hot also on the Energy Efficiency Directive, and I think the topic has not lost its power, but now even gets more pressing because time is proceeding and really something needs to be decided soon, and member states are working on this renovation plans for their country. So one of the main questions is now, and that was something we followed up then in this study, it is clear that there's a target now with reducing the carbon emissions by 90%, but still the question is how to get there, what would be the measures, how should they be combined, and also the question, how fast do we need to be, and is it possible at all to be that ambitious and to be that fast, because 90% is also an ambitious target. And the question is also if there are different possibilities, so what would be the outcomes then in terms of energy or CO2 or financial impacts and also employment effects, because these outcomes could help to define certain tracks which are maybe more likely to be successful than others. So within the study, we developed 3 different renovation scenarios, and basically they are characterized by 2 aspects, and this is on the one hand side the speed of renovation, meaning the renovation rate. So that's a percentage that expresses what share of buildings is renovated each year. And this of course is an important aspect, because it's impossible to be too fast and too expensive, because then it would not be linked to the natural change in the building stock anyway. But also, if it's too slow, it might happen that the 2050 target is not even reached. And also the second aspect is then the ambition level regarding energy efficiency improvements and also the use of renewable energy. And out of the combination of these 2 parameters, speed and the ambition level, different tracks can be let's say described. And basically there's also in some way a trade-off between these 2, because I think it's also clear that if there's a very high ambition level, that maybe the speed of the implementation needs to be a little bit reduced, because it's more complex to do, while very simple, very low-level actions might be possible to be implemented at more speed. Then on the time frame, we agreed then to look at the 2050 horizon, because on the one hand side there's a target set for that long-term vision, but also that because it's important in the building sector to really look into these long developments, because the renovation cycles are that long that you really need to have a long-term view to really see what's happening on a long term, to see the consequences of things that we even do in the next years. Then having a look at the methodology for such kind of scenarios, it's important to have a software tool which is able to combine all the different things that are happening in the building sector. Just as an example, there are buildings or tools that work at building level which can clearly calculate the energy performance of a building. But if it comes to more buildings or even a complete stock of buildings, things get a bit more complex, because you have renovation of buildings, you have new buildings adding to the stock, you have also a share of buildings which is torn down each year, while at the same time there are parameters which are subject to changes, like energy prices are probably slowly increasing, but also CO2 emission factors, for example, for electricity or also district heating, are supposed to drop in the future. So that gives a lot of input parameters which together are subject to certain changes, like renovating buildings, having new systems in, improving the performance of the building shell. So the BEAM model developed by Ecofys is such a model who can deal with such kind of changes and calculate the effect of all kinds of measures which are applied to the building sector. And it comes as a real bottom-up model. That means that there's a large number of reference buildings in, which then can be kind of equipped with certain measures that are applied to it. And then depending on the renovation rate, new building rates, and the measures that are applied, there's outcomes then for the future and the way to that regarding all kinds of output parameters, which are CO2 emissions, but also the energy cost, the financing costs and running costs, also the energy, primary energy and final energy numbers. So this allows to really see what happens if, and is specifically suitable then, of course, for such kind of scenario work. So coming to the assessed scenarios, because we discussed at that time what can be shown best, and of course we wanted to use quite typical tracks that are also in current discussion. And one track chosen was then a kind of shallow renovation track. This is a track where there's a relatively fast renovation with a renovation rate of 3%. Then a quite average energy efficiency ambition level on the building envelope, which is, just for your orientation, reaches then about 32% reduction in energy use for space heating until 2050. So that would cut off 1/3 of the energy use. And it takes into account not only less ambitious values, for example, for the insulation of facades or roofs, but specifically also taking into account market failures, where, for example, a facade is only painted or new plaster on it, but the opportunity is missed to add also insulation to it. So it's a mixture of not so ambitious targets on the building envelope and the energy efficiency, and market failures where really some things are not done. And also there's a low use of renewable energy. And that could be marked as a track which is kind of quick and easy, doing the things that are relatively easy and doing them at not a very ambitious level, but doing them relatively fast. The second track is called a shallow renovation and a high use of renewable energy, because one could say, of course, if we want to reach a 90% savings, we might do that with doing not so much on energy efficiency, but do it all, let's say, with renewable energy to make the target happening. And that's indeed one of the discussions. And this is then a track which comes at a lower renovation rate of 2.3% because we assume that a really high use of renewable energy will make it a bit slower. And then here again, the part on the energy efficiency on the building level is similar. The reduction of energy is a bit higher because the advanced and renewable system reduce the energy use more. But indeed, there's a quite limited focus on energy efficiency of the building envelope and quite advanced system then on the renewable side. And track number 3 is the so-called deep renovation, which is also a lot in discussion at European level. And this is a track combining a high level of energy efficiency, which would mean an 80% reduction in energy use for space heating until 2050, and combine this with a high focus on also renewable systems and also heat recovery with ventilation. So these are things, let's say, where not only the efficiency is very high, but also the share of renewables is relatively high. And that's also necessary because only with the efficiency side, the target of minus 90% would also not be met. So both track 2 and 3 are then also developed to match the target. So looking at the model input, so what comes into it, I don't want to go to all the, let's say, inputs, but just give you an impression of what has been taken into account. And then, of course, in the study, the background and the information and the numbers are described in the text and in the annex. But basically, we looked at 5 different areas in Europe because they're different in their climate, they're also different in the costs of energy, and they're also different in the cost of equipment that is applied to the building, so it's important to have a differentiation there. Also, you see that the type of buildings are quite different. You see on the upper right side the distribution of all the buildings that have been assessed for these 5 areas in terms of single-family houses, which have the highest share, followed by multifamily houses and the offices. What you also see is the distribution among the different zones that we defined, and there you see that the Western European zone, which includes on the left side all the green countries that are marked, like the UK, France, and Germany, that they have a majority of the building stock that is being looked at, and a large share of the building stock is also in Southern Europe. And it's good to note that in terms of energy use, the share of Western Europe is even higher because there the energy consumption per square meter is typically higher than in Southern Europe. Other important parameters to the study are differentiated by region as well. So CO2 emission factors, investment costs, energy prices. These are things that play, of course, a role. On the energy prices, we started from information from Eurostat with real data from cost for energy from household consumption, and the forecast had been made over the time that we look at based on information from the European Commission with a real term increase of 2% and for electricity of 2.8%. After a certain time, we, let's say, assumed that they would be constant because after 30 years of applying such real price increase, it would get very high if it always would further increase, and that's something which, for example, also the IEA does not assume, but that there's at a certain moment, maybe a balance of the demand and the supply. So at a certain moment, we do not increase that further. But the full information on the energy prices and what they are, you can find in the study. So coming to the results of the study and what does it mean? So basically, you see here the results for the CO2 emissions for space heating and domestic hot water. And what you see here is the red line is the shallow renovation track. The blue line is the shallow renovation plus renewables, the second track. and the green line is a target scenario deep renovation. And what you can see here is that the shallow renovation track is really completely missing the target. So because at relative high speed the building sector is renovated, but that at a certain moment the buildings are renovated, no further improvements are happening, and the path basically stabilizes at a certain level. The other two tracks with the efficiency focus and the renewables, but also the shallow renovation with a lot of renewables, are both meeting the target, both going down to this 90%. So it's also clear that it's possible to achieve these. What you can see also, this is the dotted line, are scenarios where especially the emission factor of electricity is assumed to be different. In the thick lines, let's say, that you can see, it is assumed that the target for the power sector of reducing its emission also substantially is met. But in case that would not happen, of course the emissions are a bit higher. And there you can see that especially the track with the shallow renovation but very high renewables is a bit more vulnerable to that, mainly because the electricity is used a lot in heat pumps, which of course depend in a way of the electricity they are fueled with. But the main conclusion from that graph is that the shallow renovation track really completely misses the target, whereas the other two can do. Then looking at final energy for space heating, we looked at it without new buildings because the question at that time was really, okay, how could the stock be reduced? Could it be reduced to 80% of its energy consumption, of its current energy consumption? So we showed in the study this kind of picture, and you see that the shallow renovation, again, let's say, falls really short on the energy savings that are possible. The shallow renovation plus renewables is performing better, and the reason is of course that more advanced systems are used, because we're talking here about final energy, so that includes that systems with a better efficiency are performing better, and this is visible in this graph. And then the target scenario on deep renovation is really going down as it combines then efficiency measures with these renewable systems, and indeed showed that a 80% reduction is basically possible. Then, as another result, of course, extremely important is the cost. So we see the different results of the tracks, but what are the costs along with it? And we show in this graph the total cost, meaning the costs for the investments that are done and the energy cost. So the complete, let's say, invoice that you get for developing your building stock in a certain direction. And it is growing in this graph because, of course, the investments are piling up, whereas the energy costs are reducing. But all in all the tracks go up because significant investments are necessary. And the question is, which of these does it in the best way? And of course, let's say if you would look even more to the future, when all, let's say, the investments are paid back, then it would drop again. But in this field, it's really important to see how do the different tracks develop until 2050 in that aspect. And what you're seeing is that the shallow renovation, so the red one, and the shallow renovation plus renewables and the deep renovation track, first of all, they're relatively close to each other. So maybe unexpected for some people, it is not that they completely fall apart. They have their difference, but basically they're at least in the same ballpark. Then what is clear is then again that the shallow renovation is clearly missing the target, so it's really not delivering the CO2 emission target, but it seems to be financially not significantly more attractive. On the other hand, the high efficiency and high renewables path, so the deep renovation, comes at relatively similar cost, and then a little bit on top of that, the shallow renovation plus renewable path. So this is a picture which makes clear that these different systems are really competing in the market, and there are some differences, but again, it is not clear that the shallow renovation one, which really looks like the easy one, would miss the target but be very attractive. That seems to be not the case. So this is now an overview of the results of the different tracks. And there you can see again in the overview that on the emission side, you see that the emissions in 2050 for the EU 27 countries are in track 1, the shallow renovation, still quite high, whereas they significantly go down in track 2 and 3. On the final energy use, you again see that there's a kind of step from the shallow renovation with quite an improvement to the second, but then again cutting again the final energy use in half when going from track 2 to track 3, the deep renovation. In the next column you see the related reduction in final energy use, which is then going from 32% in the shallow renovation up to 80% in the deep renovation track. And the last column finally says or shows the total cost of the different tracks, in this case really, let's say, discounted as a discounted value for the whole period, that you can actually compare these different tracks, and then they end up with 8.2 trillion euro for track 1, 8.8 for the track 2, and finally 8.5 for track number 3. So what are the conclusions now of the different tracks and the different information we get from that? Of course, beyond there are a lot of details that one can look at it, but the main questions are, of course, can the emission saving target be achieved until 2050? Is it possible at all, or was there a mistake in calculations or plans? And the answer is yes. You could show that track number 2 and 3 clearly are able to arrive at this 90% emission target, whereas the scenario 1 is clearly missing that. Then another discussion was, of course, on this 80% final energy savings. This was discussed quite at that moment in 2012 in the framework of the Energy Efficiency Directive discussions, but it's still ongoing and is part of the discussion now how to move on. And the answer is yes, the 80% final energy savings can really be achieved and can be a good ambition level, but there's some considerations on it. First of all, it's possible to do that, as it seems from the scenarios, for the final energy use for heating, and that's what the graph showed here. If it includes domestic hot water, it gets a bit more difficult because on the domestic hot water side, the savings that can be achieved are a little bit less, because especially also on the efficiency side, there's not so much to do, because you would not like ask people to have less showers or so, but you really need to do it then with the performance of systems. So that would mean if that would be included, the savings would maybe not be 80%, but would be around 75%. And there's also consideration of taking into account also cooling energy or even lighting. And then, of course, the question is how these technologies can be reused in energy use and how that would impact this target. But basically, 80% final energy savings target for 2050 seems to be possible and in reach. Then number 3, the question is, of course, can deep renovation be a suitable way to achieve EU targets? And our conclusion was that we say yes, the combination of really extensive energy efficiency measures and the high use of renewable energy, so really not an either or, but the combination of it, seems to be a preferable way to achieve CO2 targets and energy efficiency and energy savings. And again, to summarize, the track 1 is really missing the target and not showing really substantial economic advantages. Then the second track meets the CO2 targets, but it shows significant less energy savings. So if it's about this part of the targets, it falls short. And it's also resulting in slightly higher costs compared to the deep renovation track. And then finally, the deep renovation track, which really hits the target, has massive energy savings, and seems to be an economically viable way. Plus, and that's another information then that was created in the study, the deep renovation track is really a track where you invest quite a lot, but you also gain a lot in energy savings, and that seems to be a viable balance compared to the other two tracks. But the high investments, of course, also mean that there's good potential for creating jobs. And the calculated outcome was that the second track could, if compared to the shallow renovation path, could deliver an additional 1 million jobs in Europe, and the deep renovation track could deliver 1.4 million additional jobs. Something which, of course, is interesting information and numbers when looking at today's economy. This brings me to the last slide and kind of an outlook then, because the question is now, when we see that there's out a target for 2050 with this 90% reduction in CO2 emissions, we also see that there are tracks available that can reach it, and a deep renovation track, which seems to be a viable option. Then the question is how to get it really done, and that's not solved yet. So all the governments and actors are in discussion on how to make that happen. But I would like to introduce here some ideas of possible parts of the solution. And clearly at building level, it's important that the energy performance of a building is really improved whenever maintenance or repair is due anyway. So this is this best economic point where quite cost effectively measures to increase the performance of the buildings can be coupled to anyway due measures at the building level. And they really must not be lost these moments, because otherwise the building will not change anymore for quite some time. So that's important to grab these moments. Secondly, and that's at the same importance or even higher, the measures need to be really 2050 proof, so to say, because it's expected, especially at the building envelope, that they will last 30 years or longer. So whatever is done now in the next years will be there in 2050 and really needs to comply with what we want to be there at that time. And thirdly, it's important to avoid lock-in effects at building level. Example is when the lifetime of components cause the renovation action to stretch. So for example, if the roof has been improved some 5 or 6 years ago, then it will probably, in a larger refurbishment, not directly be refurbished again. But it's also important then to see that at a later stage, the roof could be also brought to a level which is important for 2050. And that means that when it's not possible to do the whole building in one go, which is of course the most secure thing to come to a deep renovation, that it's clarified and planned that there are no lock-in effects where you do certain actions which are difficult to change again after some time. So thinking ahead is important. And then on the other hand, for the governments, also something to do, of course, on the first hand side, to set requirements which are ambitious enough and help reaching these targets in the future, and also to do that especially on component level, because this seems to be something which is really clearly and easy for the market to pick up, and very clear requirements, and also fits with the effect that sometimes things are done a bit in 1 or 2 steps. Also very important is, of course, the support via capacity building, so that really skilled workers and planners are available to plan these kind of deep renovations, to inform people and to help with financing, upfront financing of the investment, but also giving incentives like soft loans or other support schemes. Could also be fiscal incentives, because, as said, the barriers are there, and it's important, to maybe at least in the first few years help people to get on that track. And finally, very important as well, to check compliance, because, well, rules and regulations have only a limited effect if it's not clear that someone really follows up and looks and checks after these. And this, of course, needs to come in a package, combining all these measures to get things going. Okay, so that's the moment where I arrive at the end of the presentation, and thanks a lot for your attention in this, and looking forward now to any kind of questions that might arise from the presentation.
Okay, Thomas, thank you very much for this interesting presentation. So indeed, a lot will depend on the way the buildings are renewed. Excellent. So let's go now for questions and answers. So you can please use the Q&A pod, which is in the top middle of the screen. And we will proceed to treat them one by one. So we have some entry questions now. Let's see. One moment, please. Okay, so we have a first question about cost optimal requirements for the renovation of existing buildings. Has it been enforced since 2010 but not applied yet? For instance, member states are still figuring it out.
Yeah, good question. The status at the moment is that in 2010 the Energy Performance of Building Directive set up a methodology how that should be done, and requires member states to do the calculations. So right now at this moment there's a project in which we look at for the Commission in these kind of reports. So last year member states had to calculate these cost optimal levels and have to report to the Commission. And basically from that moment on, member states, if they see a specific gap, so if there would be a substantial difference between the current requirements and what is possible, member states need to describe how they close this gap, how they move forward, and that could, for example, be in strengthening the requirements in one or two steps. So basically, nowadays already member states have to comply with it, and it depends also a bit on the outcome of the calculations, what will happen. In some member states, the calculations revealed that the requirements are quite okay as they are at the moment, so no additional actions necessary. But there's also quite some member states who indeed see room for improvement or strengthening of the requirements, and they then need to come up with a plan how to change that, and that's probably then in improvement steps like in 2015 that could be done to comply with that. So it's a kind of dynamic action. The time for reporting has passed, so the reports and calculations now basically would all need to be done now, and indeed the outcome of these will now decide what happens with the building codes.
Okay, good, thank you. So we have another question. Are there examples of good member state programs to accelerate renovations?
Yes. Well, indeed, there's a number of instruments that are being used in the building sector to accelerate that. Often mentioned is the program of the German KfW bank. It's a state-owned bank, which has incentives for refurbishments in a way that they are preferential loans, so loans at lower interest rate than the market, which are given out for renovations, and also depending on the ambition level of the renovation, the loans are a bit more or a bit less favorable. So there's a push, let's say, to try to go further. And I think this is a tool which has proven quite well, at least in Germany, and is often mentioned in Europe as a good case where, let's say, there's a mechanism to, on the one hand side, give an incentive, but on the other hand, also clearly help with the necessary upfront financing. Plus, there's quite some information around these programs and advertisements around that. So this could be taken as a best practice, but there are also other instruments like fiscal instruments in some countries where actions on the building then can be deducted in a more or less significant way from the income tax, which seems to also be quite a good instrument because people obviously like this possibility to reduce their personal tax. So there's different ways in doing that that could be used or combined.
Okay, thank you. So we would have another question. How to combine EPBD requirements and financial limitations, namely in South Europe, countries such as Portugal, Greece, Spain, and Italy?
Well, if it comes about the EPBD requirements, they are now at the level of this, or need to be shaped around the cost optimality guideline, and that's indeed a methodology where you take into account the investments that are necessary and the energy cost savings, and then kind of optimal performance level is being calculated. And this is done by the member states themselves, and the inputs to this calculation are the national price for certain equipment and the national energy prices. So basically in that it's already secured that the local circumstances are taken into account. So from my perception, the ambition level is actually indeed shaped to the national circumstances and climate. But if the question is, well, is there enough money available to do the renovations, and that's not only the energy efficiency part, but everything which is connected to it, that's of course quite significant investments. And on that end, possible solutions can be, especially within the structural funds of the EU, where quite some areas can benefit, for example, in the form of setting up a revolving fund that can finance energy efficiency. So that's a possibility to, on the one hand side, I would say it's already secured concerning the ambition level in the current way the codes are set up. And structural funds can, let's say, help financing it. But there's, of course, also a clear barrier now if people, for example, have to fear for their job, have not enough security on that side. It can, despite all support, be difficult to take that step and go for large investments. So that's, on that end, if that is a part of the question, for sure a difficulty that needs to be overcome. But then again, as said, renovation of buildings can be also a motor for new jobs. So it could also be a chicken and egg problem where you say, well, we want renovation to really boost our economy. But of course, the economy needs also a certain level to allow for the renovation action.
Okay, thank you. There is another question. So first, thanking for the clear presentation. And the question is, what is the current renovation rate percentage in Europe? And I would add, what's the most likely scenario for the years to come, related to the three scenarios that you presented?
Yeah.
Thank you.
Okay. Well, on the renovation rate, this is of course quite different per country, but I would say it could be around 1 or 1.2% of the buildings that are really energetically improved per year currently, and there's the intention to at least double that in many countries. And it might happen that in the last 2 or 3 years the number has a bit increased. So like 5 years ago I would have said 1%, now maybe it's a bit higher. It's difficult to measure. There are no clear statistics on that, but various information that can be, let's say, compiled to such numbers. And we see increasing activity with the awareness of high energy prices. But let's say it's also clear that to go to the numbers that are envisaged, it's really a leap jump that has to be made. And like Germany, for example, would like to increase it substantially. So some other countries really have to triple it, for example. And that's quite a lot. While it looks a small difference between 1 and 2%, it needs to be noted that it's a difference of 100% in the activity level to go from 1% to 2%. And regarding the likeliness of any scenario, well, I would say if really the targets are taken serious and there's clear action to try to get to these, then the deep renovation track is hopefully the one that is, let's say, followed, and it might take some really action to get that going in the start, but on the longer run, this could really work out. Of course, let's say one can also be pessimistic and seeing that in the current discussions, for example, on binding targets on energy efficiency, it seems to be difficult to get a grip on it. So of course it could also happen that more things would develop as the shallow renovation track describes these. But it's also clear that these would be really misleading, so I really hope that this can be avoided and needs of course then timely actions and things to come. But I would be positive on that end that this can happen out of the different benefits as just described.
Okay, thank you. Another question, does the cost projection of the tracks include cost savings due to reduced energy consumption?
Well, as described, the model is calculating fully bottom-up, so there's reference buildings in it which have a certain energy consumption, then certain measures are applied to it, which of course then lead to a reduction of the consumption, and this is all kind of added up and projected with the new building rate, the renovation rate that is assumed, and the tearing down of buildings. So the reduced energy consumption in a refurbishment, that's well within the calculation of the model, which takes this into account. So that's how it's calculated within the methodology, within the tool, and that's what comes then out as the final result of the energy use of the different tracks, which is also shown separately in this study.
Okay, thank you. Another question, has the issue of whether and how renovations are considered in the value assessments of buildings being discussed in Europe? It's a big issue in North America. Have any changes been made to the property assessment methodology to capture the value of energy renovations?
Okay, I assume that the question targets to whether a building or the value of a building increases when a renovation has been done because it has a higher quality and therefore should have a higher market value. This effect is indeed visible. Let's say that it gets more and more a topic that people not only look at the building as such, but are also considering the running costs of a building. So we see that there are effects of it. There's also, I think, a study from the European Commission that was done, I think, last year, which had a look at that, how much or how many percentage of value increase can happen from, for example, when buildings are certified at to have a certain energy level. So this mechanism is clearly there, and it's indeed discussed a lot in Europe, because right now this is not often taken into account in any kind of calculations or models. Also in this study there was no assumption on the increase of the value of the building, so any of these effects, let's say, would come on top of the benefits that have been calculated. And it, of course, also plays a role for this cost optimality calculations of the member states, because if there would be clear indication that this value raises, then this could also give a push to achieve a more ambitious level if this is really, let's say, paying off directly. So it is a discussion and there are studies out, but it's also not yet fully and easily implemented in the valuation of buildings or the ambition level of requirements. So, but probably would be very good if this would happen in the future.
Okay, thank you. There are two remaining questions. So next one is there any current weaknesses or issues with the energy performance certification program that would need to be addressed to enable deep retrofits?
Yeah, well, the need to have building certification, especially in the moment of sales or renting out of a building, is, of course, fixed in the Energy Performance of Building Directive. So the energy performance certification normally should, let's say, show what the level is and should also explain how renovations could be done to improve the situation. And when it comes to weaknesses or things that could be improved around these certificates, then I think indeed there's improvement potential. Mainly it's about the way how the certificates are done. There's still a lot to learn for the EU member states from that end, because there are different ways to do it. They could be quite complex and calculated certificates, which are of course more costly, but some also apply the possibility to just look at the consumption of last year and make a benchmark from that, which is considerably faster and cheaper, but also has less information in it. So that means on the one hand side that the performance certification is not optimal everywhere, and especially then the recommendations of what could be done and what the outcomes would be, I think they're not yet clearly shaped, and also not clearly shaped especially towards deep retrofits. So it's not clear that they point exactly in this direction, and the reason for it is that, of course, the discussion on how deep retrofits could look like and how they can be achieved is not fully settled. But I think performance certification could be a useful tool if they would really give good information to the customer at a reasonable cost, and at the same time could give very clear indication of how to retrofit the building. And some people argue even that there could be, let's say, a formal requirement then to actually follow that plan and have it not only recommendations, but like a clear pathway that the building owners have to follow. But that's, of course, a difficult discussion because, that would make the certificate a very legal binding document, which is also not something that every market actor aims at.
Okay, good. Thank you very much. And then the last question for today. In your 2050 projections, climate change effects were taken into account? If so, how?
Well, we looked, of course, for the calculations. You need to assume certain heating degree days of the building or of the climate. So the question is, what was the climate in the past? And typically, there's long years averages that have been used. We did that as well, but did not go too far back because we see an increase of the temperature in the last years, and we didn't want to be too defensive and have, let's say, calculate with numbers which are then much colder than they are today. But still, let's say we did not perform a projection until 2050 of the climate in this study. So depending on what actually happens and how things develop, there could be effects, let's say, on top of the calculated one. So the answer is no, it has not been, let's say, there was not a specific scenario that we were following. But we were taking into account, let's say, in choosing the heating degree days with which we calculate that there was already in the last years a trend. So I think it's reasonably covered, but there was not a specific scenario projection into the future for that study.
Okay, good. Thank you very much. So I think we went through all the questions. Thank you very much, Thomas, for this great presentation. Also, thank you to our audience for your interest and participation. And now, Thomas, I will give you the floor to finalize the session. Thank you.
Okay, thanks a lot. Yeah, I would indeed say thanks a lot to all of you for joining and listening to the presentation and about the questions that have been posed, and I hope that the presentation was giving some ammunition to your thoughts and ideas. And you're welcome, of course, to look at our website or the website of Eurima to download the study and work into it into detail if it's interesting for you. And we hope that we can trigger some good discussions and thoughts for this important topic via that and the presentation today. And thanks also again to Fernando, the organizer, for setting this up in this very smart way of this webinar. Like it a lot. Thanks.
Thank you. Goodbye for now.